Trig Substitution. Alright, so we use trig substitution in order to find the antiderivatives of integrals. We don't know probably what the antiderivative of this is. So if you have square roots, a lot of times with something squared, either adding or subtracting, that's an indication that it might be a trig substitution. It might be an inverse trig function also, or it could be both. Like you could do it either way. So some problems you can use trig substitution, some problems you could do a U substitution and it could be an inverse sign. But it is an option that you can try if you see a problem. So we're creating quite a list of different integral techniques that I think I attached in your assignment, that it's the list, and we can go over those next time we're together, of all the different techniques. But for trig substitution, what you need to do is you have to draw a triangle, and it's always a right triangle, and it's the Pythagorean theorem, so it's a square root of 4 plus x squared. So that tells me that 2 and x are the two side lengths. So this could be 2, that could be x, this could be the 2, that would be x, or this could be x, that could be 2. It doesn't matter which one you choose. And if those are the case, then the hypotenuse would be square root of 4 plus x squared. Okay, so we have our triangle drawn. That this is the hypotenuse. So if this was a minus in there, then this would not be a hypotenuse, it would be one of the two legs. So if it was like the square root of 9 minus x squared, then the hypotenuse would be 3. This would be the square root of 9 minus x squared, and this would be x. So it depends if it's minus or plus. If it's plus, it's going to be the hypotenuse. So the next thing you want to do is choose tangent, sine, or secant. Other ones will work, but these ones will always work. Tangent, sine, or secant to find a relation with the variables on the sides. So you never use the square root one, and you always choose the x one on top. So if I choose this as my theta, I'll do it with a pencil and do it wrong. If I just pick that as my theta, remember we're not going to use the square root one. We can use tangent, so the tangent of theta would be 2 over x. Well, that doesn't work because we need the x on top. We could do the sine of theta, and that would be 2 opposite over hypotenuse, square root of 4 plus, that doesn't work because we're involving the square root, and secant would be also involving the square root. So none of those work if I choose theta to be right there. If I choose theta to be right down here, then I can use tangent, and the tangent of theta would be x over 2. It's one of these three trig functions, and it doesn't involve the square root, and it puts x on top. So it kind of uses a little bit of trial and error to figure out which of those to do. So once you have that, you want to probably solve for x, so I'm going to go x equals 2 tangent theta, and we want to find dx d theta. So here's my list. So number 1, so like recognize to use it. It has square roots of things being squared on the inside. Number 2, we want to draw a triangle. And involve tangent, sine, or secant. And the x goes on top, and don't use square root in equation. And then find equation, like find equation. So we just found it. Now we want to find dx d theta. That's an ugly theta. So we're finding the derivative with respect to theta. So on the right it'll be dx d theta. On the right it'll be 2 secant squared theta. And then you can solve for dx, so dx equals 2 secant squared theta d theta. Solve for dx. Okay, so now set up integral in terms of theta. So our integral was the square root of 4 plus x squared dx. So now we have the integral of the square root of 4 plus whatever x is. Well, we said x is 2 tangent theta, so we're going to plug that in for x. And then dx is all of this stuff. This is our dx, so it's times 2 secant squared theta d theta. Alright, we've taken a nice kind of a clean integral and turned it into all of this with the hopes of figuring out what the antiderivative is. Integral square root of 4 plus 4 tangent squared theta times 2 secant squared theta d theta. You could pull a 4 out, take the square root, so that becomes a 2 on the outside. And then there's another 2, so 4 integral square root of 1 plus tangent squared theta secant squared theta d theta. One plus tangent squared is secant squared. Square root of secant squared is secant x, or secant theta. So now I have 4 integral secant cubed theta d theta. Okay, so we don't know what that is. Which is, now we need the brief table of integrals, and according to number 92 here, we get this. Maybe I'll just take over, not write it all out, and kind of follow along here. Okay, so off of the brief table, integral of secant cubed is this stuff. And we don't know integral of secant either. So apparently number 88 will tell us that that's what the integral or antiderivative of secant is. So we have our antiderivatives in terms of theta after all of that. But our original problem was in terms of x. Oh, multiplied by 4. We still have this 4 up here that we have to distribute. Okay, so we get here. We want it in terms of x. So we have to go back to our original triangle and what is secant theta? There's theta. The secant of theta would be the reciprocal cosine, so it would be that over that. So when we have secant theta, we get the hypotenuse over 2. Tangent theta is, we said tangent theta is x over 2. So we can plug x over 2 in for tangent theta. Secant theta, same thing, tangent theta. And we've got all the, that's our answer. 2 of those cross off. We get to here, maybe check the book to see if we got it right, and they don't have that. So what you need to do is combine these. And then if we're taking the natural log of something divided, we could do the natural log of this minus the natural log of that, because that's a property of natural log or any log. And this 2 is still here, so it's 2 natural log of that minus 2 natural log of that, and 2 natural log 2 plus c, like all of that is just a constant, so it gets absorbed inside of the c, and it just becomes a different c. So that would be our answer.
Wait, I thought, so the part where it's like the secant and the tangent, I thought that we already took the derivative at that point.
You aren't finding the derivative. You aren't finding the derivative or the integral. You're just replacing what we defined secant theta to be. So based off of what our triangle was, that's what we have defined our variables to be. So the tangent of theta would be x over 2. If we wanted cosine of theta, it would be 2 over that. The secant is that over that. If it was sine of theta, it would be that over that. So just using...
I get that. I mean, when we went from secant to the third to secant theta tangent theta.
Yeah. How did we get that?
Isn't that the integral?
It's part of it. It's plus all of this. All of this is. Oh, I see why you're... Yeah, you're just not used to using the table. The table, if you check it, is going to have an integral in your answer. They're not going to give you the entire antiderivative. Like if it was secant to the 5th, you might have like a secant cubed left over here, and then you'd have to do another one.
Okay.
Good question. You'll see that once you're memorizing all 141 of them. You'll get used to using it.
On the other page, when you're talking about, sorry for a little bit, you might have said this, but when you define theta, did you put that opposite of x? Is that like how that works, or?
Yeah, when I defined theta.
Yeah, how did that?
How did I know to put the theta here or up there?
Yeah.
Good question. So what you can do is just try it somewhere, and if you can choose tangent, sine, or secant, where it will work, where you're not using the square root side, and the x goes on top, then you know you're in the good spot. So the one I defined right here, just as an example, I'll use pencil here. So remember, we're using tangent, sine, or secant. So if I choose this as my theta, we want to only use these two sides. So those two sides would either involve secant or cosine. Well, secant's an option. So I'd say the secant of theta equals 3 over x. Well, that didn't work because we need the x to be on top. And I'm not going to, you can't use tangent there because that's not the right two sides, and you can't use sine here because it's not the right two sides. So theta would have to be on this side, and now these are the two sides we're going to use. So that's opposite and hypotenuse. So that'd be the sine of theta equals x over 3, and that's the equation that you would use.
So you're basically looking for the angle that gets x over a constant?
Yes.
Using tangent, sine, and secant?
Exactly. Yep. And if you want, I mean, it's not to say that you could say cosine of theta. If I said cosine is right here, equals x over 3, that might work, actually. But my advice is to use these three. And I think these will always work. Cosine, it may always work, but it might not be as easy. Or sometimes it might not work.